we're going to go over some just simple custom code and how some of the logic blocks work, and just go from there. And we'll just kind of, if we have any questions, just shout it out or type it in chat, and we'll go from there. So to start off, we're just going to do a custom program. So we're going to go up to top left and click New. And on here, I'm just going to call it we'll do a simple exhaust fan example. Call exhaust fan. On the system type, we're going to do the drop down, go all the way down to custom application. And this is going to give us just a completely blank program to work with. And sorry, on this first screen, I'm not going to select anything. I want to create everything manually, but this wizard gives you some options to add things from the beginning. And same thing, this would be the same thing, but for outputs. All right, so again, when you get to this screen, we're mostly going to be working in this application window for the most part. So on the left, you got your inputs, on the right, you got your outputs, and the middle is where we're going to do all our programming. I'm going to go ahead and make it bigger for the time being. You can double click on top of the window here to make it expand. You can also click and drag it around. Same thing with this bottom one. It's nice working with two screens because you can put this one on the other screen. Up here at the top, there's the view button or view drop down. You can reset the layout if you ever get them all mixed up. Okay, so for this example, I'm going to start with something simple. We're just going to add a network input, which is a software point, and we're going to turn on the exhaust fan output. And we're going to link it together so you can see how you can do connections. So I'm going to hit, let me back up. So whenever you hover over any of these sections, there's a little button right here that lets you add a point to that section. You can also right click on them and do new. It does the same thing. And when it pops up, you get this little new module selection wizard. And in this case, we're making a network input, so it only has 3 options: Boolean, enumerated, and floating point. I know that the point that we are going to be turning on is going to be an off-on point. Even though it's, we're used to being the Boolean true false in Johnson, they default them all to an enumerated point. And when you're doing connections between points, they have to be the exact same enumeration set, or Boolean can only link to a Boolean. You can convert them, but you have to do that in logic. So I'm going to add an enumerated point, and we'll just call it exhaust fan dash, and we'll just type it all out, enable. And then from now we want to make our output, so I'm going to go over the outputs and do the same thing. And we're going to go over here, and I'm going to type exhaust fan. Oops. And it's going to give us a bunch of options, and almost all the time when you're doing you're going to be using 24-volt AC maintain. Okay, and you can change this stuff after the fact, but it just gives you the option to add it in at the beginning. So you can right click and do modify signal. So from here, if we wanted this point to turn on this output, you would click on the connections tab. And when you're on the connections tab, when you select an object, it shows what it's connected to over here, over here. So on this network input, down here right here on the output coming out of the network input, you can right click and do make connection. And it's going to pop up with this little wizard that's going to give you everything in the whole program that you could possibly connect to that was off on enumerated set. So under hardware, we know we're just going directly to the output. So I'm going to expand hardware, and then under outputs, the output section, I'm going to select the exhaust fan command and hit OK. And so this is, instead of like in a JACE where you're doing link marking, you're basically just making a connection from the input to the output. And if we simulate this thing up here at the top, I hit the simulate button, it comes up with this little thing. You can go up to 10 times speed, and it lets you put a default value in here for your different points. I'm going to leave it off to start. And so right now we have our exhaust fan off, or enable off, and our exhaust fans off. So if I right click and do a command, this is in simulation mode again, and hit OK. Exhaust fan turns on, exhaust fan commands on. Okay. So just a little simple example on how to make a connection on here. Let's say we wanted the exhaust fan to turn on, let's say it was a mechanical room and we wanted to have it turn on at 80 degrees to cool off the mechanical room so it doesn't get any hotter than that. So to do that, we'll have to create a activity block or a hybrid activity block. And we're going to go through both and show the difference between the two. So we have an exhaust fan enable. We're going to need a temperature and set point now. So on my inputs, I'm going to hit the plus sign. I want to add temperature. And if you type temperature, you can see like it gives you a list of a billion different temperatures. There's also, if you type miscellaneous, there's a miscellaneous for just about every status or temperature you can think of. I think it even has like a, in our example, if you type mech, there's a mech room temperature. So I'll just do, Johnson defaults to 1K nickel. Another popular one is this 10K NTC type L. I don't know why they named it like this, but this is 10K type 2. So I'll go ahead and add a temperature in here. And this is going to be actual physical input. And then we're going to need a set point. So I'll create another network input, which is a software point, and it'll be our set point. So I'm going to hit the plus sign again. On the input float, a floating point is just a numeric value, 100, 50, 1,000. So I'm going to hit 1 on here, and I'll call this, on the right side, it gives you a chance to name it. I'll call it our exhaust-SP. And then you can see here it has a little triangle symbol showing that it's not connected to anything. Whereas this one doesn't have a symbol like that. It would be normal to have a bunch of temperatures that you were just monitoring, whereas if you have a set point or any network input, it's unusual to not hook it up to something in logic, because why would you have it there in the first place? So that's why this little warning pops up. It doesn't mean anything's wrong, it's warning you that, hey, you probably are wanting to do something with this. Okay, so on our set point, you can also right click, you can rename it, and you can do view details. You can, with double clicking is the same as clicking view details. So if I double click it, it pops up here, and this lets us set our default value. I'm going to hit edit here, and I want to set our set point to 80. And on our units, we can go ahead and find our Fahrenheit, which in Johnson, it starts with D for degrees. And then there's degrees Celsius and all these kind of things here. There's degrees Fahrenheit. And I'll hit apply. And so now we got that in there as the default. So now we have our inputs and our outputs. We just need to make our logic to cut the exhaust fan on at a certain temperature. So under each one of these sections, there you can add a plus sign to add a block of logic to write code in. Johnson was trying to have a flow to the program from left to right. So you can actually do whatever you want in any section. I usually just start on the left, and if I happen to need another block of code, I'll go over the next one and the next one. So we'll just start here on the left, and I'll hit the little plus sign, and it's going to pop up with this another one of these wizards. And Johnson has all these logic blocks that they've created for all the question answers to build air handlers and stuff like that in here. So the one we're going to look for right now is this is called an activity block. All right, I accidentally clicked on this activity a hyperlink over here. Let me get this over here, and this popped up, and it shows exactly what that block is. So if you have any questions on what any of these are doing, you can click right here on this hyperlink. I want to add an activity block here, so I'm going to put one in there, and I'm going to call it our EX activity. Okay, so now, again, this one has a little warning that we have this block of code that isn't hooked up to anything. So what we need to do is you can right click and you can view logic, or you can go over here to this tab right here in the top left to go to the logic. So I want to specifically go to the logic in this one. So I'm going to right click and do view logic, and it's going to bring up this blank page. For the time being, we're going to be working in here, so I'm going to make this screen bigger. And I'm going to pull this over a little bit. So up here on the top left, you can see it's divided up into these different sections that have the output control, set point miscellaneous, and state generation. That was, if we go click this control tab, we're back here. And then here's the set point miscellaneous, state generation, and output control. So when I click this, I know I was in set point miscellaneous when I created my logic block. I'm going to expand that, and then there it is. So now I'm on this like blank wire sheet that I can do things with. On the left here, we have our palette. This is similar to Tritium if you've ever done kit control and stuff like that. To start, you're going to need to get your real inputs coming into the code, and then you're going to have an output going out to the exhaust fan. So that's what these activity input and activity outputs are. So I'm going to expand the inputs, and I know I have an exhaust fan enable. So, and that was an enumerated point. So I'm going to drag this out here, and you can right click and rename it. And I'll call it EX and or enable. And then I like to put _in just to say that I know that this is an input when I'm making my connections. If you looked at that, if you double clicked on it, you can edit it, and it's the same thing. You can rename it here. You can give it a default value. However, if it's hooked up to something outside of this block of code, it's going to overwrite this. This is just a default value. And you can see the state text here is off on. That's what we're looking for, because that's what that enable point was. The next thing we need to bring in is our set point and our temperature. So I'm going to bring a float point out, and I'm going to rename this, and I'll call it our EX set point in. And then I'm going to drag a third one for our temperature, and I'll rename this one like mech temp. Okay. And then we'll be done with our activity inputs. Now we need to create a activity output, which I know is going to be another enumerated point on our output. So I'm going to bring an activity output enumeration point, and I'm going to rename this one, and we're going to call it EX fan out. So from here, what we're going to need to do is we need to figure out what we're going to how we're going to turn this exhaust fan on. So like I was saying before, we're going to say if it gets above 80 degrees in the mechanical room, we're going to turn on the fan. So we're going to look for a compare block, and we're going to do greater than or equal to. So if we bring this out, and actually I can zoom in here a little bit so you guys can see this better. There we go. Okay, so the greater than or equal to block has 2 points. It compares the first input to the second one. So let me bring this up here. So if the mechanical room temperature gets above the exhaust fan set point, this value coming out will be true. Now, the problem we're going to have here is this true or false is not an off on. So what it does in the logic is it actually creates a conversion block for us. So if I click here, I can click on the exhaust fan, and it's going to create this Boolean to enum translation. And if we look at this thing, it has a little table here. And what it's saying is when you get a false value, it's off. And when we get a true value, the output's going to be on. And it does it for us. Now, one thing we forgot to do right here is we forgot about this exhaust fan enable. So what we need to do here is we actually need to add a AND block. So there's a Boolean folder over here on the top, bottom left. I'm going to expand it. And we want to make sure that the exhaust fan is enabled and the temperature is above 80. So I'm going to drag this AND block out here. And I'm going to click from our greater than or equal to, and I'm going to click from our exhaust fan enable. Now see here, I did another translation because this point is enumerated off on, and the Boolean logic only deals with true false. So if you haven't done any type of Boolean logic, you can look it up. It'll teach you about ands and ors and nots and all kinds of stuff. Okay, so the last thing we need to do is I'm going to right click on this link and delete it here. And I want this AND block to go into this translation. So now we have all this code right here, turning this exhaust fan on. Up here. Another feature you can do if you have a lot of code going on and there's lines all over the place with links, you can right click on them and do hide. And what this says is, hey, number 1 here is connecting to number 1 here. If there's multiple, it'll have a little colon, and then it'll say like 4, and you'll have 4 ones somewhere else in your code. So for now, I'm going to unhide that. I want to simulate this so we can take a look at it. And I'll hit simulate and hit yes. We haven't actually hooked our real inputs and outputs up to this block yet, but when you're in simulation, you can actually override your activity inputs and outputs to test. So right now, because we didn't hook up anything, we have 0 and 0 here. So I want this set point to be 80. So I'm going to right click on it and change this to 80. And then I'm going to go ahead and make the temperature in the mechanical room to be 81. And we'll see that now this value went to true here. But the exhaust fan is still not on because we haven't enabled the exhaust fan. So this could be like your schedule, or you know, something like that, or maybe you have a shutdown hooked up to it, and you want it to, if the shutdown button on the building was hit, kill everything. So we're going to go ahead and turn this on, and now we got a true coming into this AND block, and because both are true, it passes on a true and turns on our exhaust fan. Any questions on that, just let me know. I'm going to hit configure. This brings us back out of simulation mode. Okay, so now I'm going to go back to our logic, and I want to hook up our points to this. So as before, when we clicked on this exhaust fan enable, if we look at it, it's connecting straight over to the exhaust fan command. So I want to break that connection, and I want to hook it up to our new exhaust activity block here. So same as before, I right clicked and did and I did make connection before. I'm going to do a break connection, and now you can see this broke off here. So this time I want to make a connection, and I want to go to our activity block. So we can see our exhaust fan command here, but I want to go to the exhaust activity, and then here's the only thing I can hook up to on this block. So hit OK. Now we're going to hook up our set point. I'm going to right click. I clicked on it, and again I'm on the connections tab. Hit make connection. I'm going to click on our activity block, and there's two inputs I can connect to. And again, I'm working on my exhaust set point, so I want to make sure I click on the right one. Okay, and then the last one I want to hook my mechanical room temperature up. Hit make connection, mechanical temp. Now, when I click on our code here, I need to hook this exhaust fan output up to the exhaust fan command. So I'm going to right click, make connection, exhaust fan command. So now we've created this little simple program. And in reality, guys, this whole thing that we just did here, you could go to side loop and select analog to binary control, temperature, direct acting, and hit finish, and it would do this whole thing for us. It would create a set point, a temperature, and output, and it would have all the logic that we just created, same thing. This is just for example, and it's kind of good, a little pretty easy to get in there and play with the logic blocks. Now we're going to do the same thing, but we're going to use a hybrid activity block instead. So same thing as before, I'm going to hit the plus sign, and instead of selecting an activity block, I'm going to scroll down here to H, and there's hybrid activity block. And we're going to take a look at that. So I'll do this one. I'll call it EX hybrid. Okay. So we're going to take a look at the logic in this guy and make this bigger. And when we come in here, it has this block here. And it's got this off on here. And you can double click it and double click this, and you can double click this. So the way this works is the code actually has different layers, I guess you could say. So whenever the state of the code is off, one set of code runs, and when the state of the code is on, another set of the code runs. So like before, we're in the interest of time, I'm going to go ahead and do some copy and pasting. So over here on our left, we can click here, and this is our old code, and then this is our new code. So I want to copy these inputs in this out. Actually, I'll copy this whole thing. I'll copy the inputs and outputs. So I highlighted them all, and then I'm going to do copy. I'll come back. Oops. I'm going to come back over here to our logic. I'm going to paste this in here. And now we have our logic in here. So what we're going to do is this exhaust fan enable, instead of hooking it up to like an AND block to enable the code or disable the fan, I'm going to click this, and I'm actually going to hook this exhaust fan enable into this state block. And now this thing is going to be telling us what state the code is in. So when the exhaust fan enable is off, I want the fan to be off regardless of what the temperature is. So on our left over here, we have some constants, and I'm going to drag at a constant enum. I'm going to double click it, and I want this to be off, so I can rename it here. I'm going to call it off, and then I want the value to be off, and hit apply. And it was already defaulted to off. You can also right click and rename here. All right, so now we need to do the code that when the exhaust fan is enabled. So I'm going to double click on, and you can see that block disappeared. This is kind of different than what most people are used to seeing in code. So what we can do here is I can go back to our other block, and I know I need this greater than. Well, I don't even need to do that. We can do it real simple here. Sorry. Go back to our code again. I know we need a greater than or equal to. So we'll go back up here to our compare folder. And I want to do a greater than or equal to. And if the mechanical room temp is greater than or equal to the set point, we're going to turn the fan on. So whenever the exhaust fan enable is off, it's going to run this code until it's be off. And whenever the exhaust fan enable is true, it's going to run this logic. So it's the same thing, just different ways of doing it. And it's really, for this simple example, it's not really something you need to do or anything, but it's actually pretty neat in larger blocks of code. And I can show you some examples. And again, like if you double click on the state, you can see what is telling the state what to do. Off, we're going to run this code. On, we're going to run this code. Okay. Any questions on the hybrid activity, please let me know. And again, if we look here, all of our links are actually hooked up to our first block of code, and the hybrid, it's all, nothing's hooked up to right now. Okay. So for an example, we're going to go ahead and do a side loop, and I'm going to do a temperature feedback loop. We're going to do a chill water valve. I'm going to select direct acting for cooling. Proportional actuator is fine. Actually, I'll do like a, let's do like a 4-stage or something. And everything else is fine. And hit finish. So we'll call it cooling CLG. Okay, so what this did is it created us 4 outputs here and a cooling set point and a cooling temperature to control to. Okay, so if we click on one of these cooling commands, I can right click and I can do show involvement, and I can see it's linked to this guy right here. And this is a stager, and then when I click on it, I can see that it's actually coming from a. Sometimes this flows better and it shows the connections all the way over to the left. This was a bad example, but we can see that the PID right here is this guy right here. It says cooling PI staged output. If you look at this logic here, and of course, let's go in here. It has a state table here on this right here. So instead of just off on, this enumeration set is off max control hold. So when we're in control, we can see that there's a PID, and it's given us the 0 to 100% command to control our stages of cooling. When it's in max, if we look at the percent command right here, it's just sitting 100%. Hold just holds, like if there was an override, and off is off. So it's kind of neat to be able to use the same bits of code without having to have a whole bunch of ands and ors and stuff added, when you can use the hybrid activities to break stuff down. All right. So if we do show involvement on our exhaust fan command, it does go, it shows us that we're looking at the exhaust activity, and it's looking at this and this and this. So it kind of helps you figure out what's going on with the output if something strange is happening. To show a couple more examples, well, actually, let's say I wanted to save this exhaust activity, and so I wanted to use it on another program. Of course, you could open this program and start from it, but maybe you wanted to just add this block to another piece of code. you can right click and there's an export module option. And when you do, it's going to give you a little place to save this so you can re-import it. When I was taught, they told me it's always a good idea to just put a Z in front of it because it puts it at the bottom of the list of all the codes. And I'll show you what I mean. So I'll hit save, and it's going to save a copy of this. If I wanted to add that block in here, I would hit the plus sign and scroll all the way down to the bottom, and you can see there's all these Z's, and the one we just did was exhaust activity. And it gives you a chance to put a name here if you want. I'll just hit finish. And now I have a same copy of this code in here. So if we look at it, so we'll look at this code and this code, it's the same thing. Let's see, let me show you some other examples here I've done. Here's a kind of a cool little, or actually, you know what, let's do the light switches for a second. So this example here is like let's say you have a room with 2 doors and you have light switch on each door. One kicks them on, the other kicks it off. So how would you do that? If you look at this code here, I did it like 4 different ways, and actually we can simulate this so we can see it work. So this first example is probably the most simple. So we have a light switch and our light output here. If I turn one switch on, it turns on and hits an XOR, and an XOR is exclusive OR. What that means is it'll only output a true if only one of the values coming into it is true. So right now we have the light on. If I kick the other switch on, whoops. Now that we have 2 trues coming into this, it turns the light switch off. And vice versa, if I turn this first light switch off, now it turns back on. So you can do that whole bit of code here with just an XOR block. Now if we run down a little bit here, this is doing it with ands and ors and not blocks to do the same thing that an XOR did. So this whole okay, this and this and this and this and this is basically the same as doing this XOR block. And we can test this one too real quick. So turn this one on. So it's true. And the not goes here. So now we got 2 trues, and it's going to go turn it on. And the same thing here. Now it goes off. And if I turn this one back off, it should turn off. And now it turns back on. Now this next block, this is another way of doing it. It's called a command hierarchy block. And I'll show you another example of using this in a second. But this thing is really powerful. It's really fun to use. So the way this thing works is, well, let me show you. So the way this works is it has a little table over here on the left. And you create, these are your 2 inputs. For whatever reason, it's labeled I2 and I3. So yeah, so you got I2, I3. So if I2 is true and this is false, so true, it's going to output a true. So you basically create a little table of possibilities to create your output. And you can add as many inputs as you want to. So you could have all these conditions going into this block, and you create this little table to what actually needs to happen. And again, if I turn this one on, we'll see it turn on there. And then if I turn this one off, or turn this one on, sorry, it'll turn on. And I'll switch this one back off and back on again. The last little example is I've never had to use this thing in code, but it's in there and it's called an expression block. When we look at it, it actually lets you do math and all kinds of Boolean like written out. So you could write a whole expression of code in here, I guess, and it's less CPU intensive. So if you have a bunch of math and stuff like that you have to do, which is really unusual, but know that this block exists. So I'm going to show you a little cooling tower example that uses that command hierarchy block really well. Okay, so let's make this in. There it is. Okay, so take a look at this. So what the situation here was is this is actually a customer had 3 cooling towers, and each cooling tower was going to kick on at a different temperature. So one was like 78, another one was like 80 or 82 or something. The last one was if it got above whatever temperature. So there's 3 levels to kick on these fans. In addition, there was also a lead cooling tower which was rotated every so often. So what we did here is we created our 3 conditions. We had the cooling tower 1 set point, cooling tower 2 set point, cooling tower 3 set point. So, and really these should be probably named like stage 1, stage 2, stage 3, because it's not necessarily pertaining to 1, 2, and 3. One thing I forgot to mention on the greater than block, there's also a differential in here that you can put. So let's say if your set point was 70 and you were trying to, well, let's say it was 72 and you were at 74 and you're cooling down and the differential was 2 degrees, it would have to go all the way down to 70 before it cut off the cooling. So usually it's a good idea to set a differential in there, and you can hook up logic to it to adjust it. So what we did here was we had 3 command hierarchy blocks, and we had 5 inputs. So I'll zoom in here. So each cooling tower had a command hierarchy block, and we had if it was in lead, if it was enabled, if the cooling towers were enabled, and then if it was stage 1, 2, or 3. So if we look at it, as all we had to do was I had to, well, by default it only has 2 inputs. So if I wanted to add additional inputs into this table, you click this IO modification checkmark box, and you can add a input, either a Boolean or enumeration. So if I add another one in there, I'll just show you by example. It adds another line in here. And the reason it's orange in this example is because nothing's hooked up to it. So uncheck that. So how this works is that you start at the top and you work your way down. So state 0 was, this is the lead cooling tower. There's some generic enumeration sets, but for whatever reason, like in computers, a lot of times they start counting as 0 instead of 1. So cooling tower 1 is 0, cooling tower 2 is 1, and cooling tower 3 is 2. So if cooling tower 1 was in lead, our cooling towers were enabled, and it was calling for stage 1 of cooling towers. We're going to turn on the cooling tower and again, this is for cooling tower 1. If stage 2 was in lead and the cooling towers were enabled, but we had already gotten to stage 3 of our cooling towers, then we kick on. And the same thing for if stage 3 was in lead, and it was on stage 2 of cooling, it would be on. Otherwise, we'd be off. And so we did the same thing for each one. So we just had to create a command hierarchy block for each one. And to do this with regular code, we would have had this whole page full of ands and ors and comparison blocks and all kinds of stuff. But we were able to do it with just these blocks that can save you a whole lot of time. We can simulate it real quick if you want. We got a little bit of time. And again, if you guys have any questions, let me know. So I'm going to go ahead and set this first set point to 70. And then the second set point. Sometimes if you click on two things, it doesn't let you click on. I'll do 75. And then 80. Okay, and then our condenser water temp in, I'll start off at 60. So none of the, oh wait, I need to enable the, so we had an enable system, and then we also had an enable towers, which, as you can see here, this enable system, this is what I was talking about. It says it's number 5, and it goes to 3 places. So you can find 5 here, 5 here, and 5 here. So in reality, we should have added another input to each of these command hierarchy blocks and hooked this system enable up to them, but I forgot. So I just threw an and on the end and compared it after the fact. Okay, so if we look at this first command hierarchy block, it's nice because it shows you what state it's in. Because we know we're not needing any cooling right now on the cooling towers, everything is off. So let's go and put this to 72. So we're going to be calling for stage 1 on each one of these. Our cooling tower lead unit is 0, which is the cooling tower 1. So if we look at this guy, it's on. So if we go in here and double click it, you can see, hey, we're in state 1 right now, so the cooling tower 1 is on. If I go and look at our command hierarchy block for number 2, it's a little different. So each one of these command hierarchy blocks, we had to go through these stages to create which one's on and which one's off. If I went to the tower lead and I commanded it instead of to be the tower 2 is the lead unit, cooling tower 1 goes off, but cooling tower 2 comes on. So I'm going to go ahead and bump us up again. We'll go to 78 on the temperature. And so now if we look, we're on stage 2 of cooling towers. So because cooling tower 2 was in lead, the next stage in the rotation is cooling tower 3. So it kicked on to help with the staging. So from there, if we go ahead and kick it on all the way and set it to 85, now all 3 are on. That's pretty cool. I really like the command hierarchy block whenever you can use it. A lot of times you'll run into issues like the question answer on plants sometimes doesn't work out with how the plants are actually needing to be ran. Go ahead out of simulation mode. All right, well, if everybody's good, I'm gonna go ahead and end it there. Appreciate y'all for hanging on, and we'll talk to you later.